So today we will see what is DevOps, what exactly it means, what it is not, and then what tools are required, what tools are not, rather than saying it's not required, what tools will help you to achieve DevOps. And if time permits, we will see what is the CI/CD pipelining. So as I said, first of all, we need to understand what DevOps is not before going ahead and seeing what it is actually. So quite often people say that it is certain amount of tools. For example, if I deploy a Jenkins tool in my delivery pipeline, or if I install or configure some kind of a system where the code goes from developer's machine to the production, where one guy constantly monitors everybody, pushes it, and then tries to copy it from development machine to build machine to test machine in a very efficient way. Let us say one guy continuously do that. That is not going to be exactly a DevOps. The idea is that is not a DevOps idea. In other words, if you put some amount of automation, like one script will copy it continuously, only doing automation part is not going to be DevOps. Or as the other example I gave you, build and release, that is some human or some tool is going to just copy continuously from one place to another place and deploy it. That one doing that alone is not going to be called as a DevOps part. Or the other idea is if you're going to have an infrastructure development, saying, let us talk about an AWS world. You are going to provision that infrastructure either using Elastic Beanstalk or a CloudFormation template or a Boto. Just doing the provisioning part using an automation is not DevOps. Just ticking each of those circles that you see there alone is not going to be DevOps. It is going to be a lot more than that. It is going to be a combination of many of these things, and it is quite often surprising because, as you can see here in the image, it's quite often surprising here because a lot of people don't believe that just automation alone is, they believe that just automation alone is DevOps. If I automate my infrastructure provisioning, I have achieved DevOps. Or if I automate my build and release process, I have achieved DevOps. I would say DevOps is a lot more than that. In my opinion, DevOps is more about communication. This is communication between the dev and the ops teams, and not only the dev and ops teams. It is going to be a collaboration with the business owners, the stakeholders, and also the other people surrounding it or impacted by it. If you remember, in the previous video we discussed about business a lot. The entire IT systems are there to support the business here. So we need to collaborate with the business owners or the managers who are going to manage those features or changes. So you need to have some kind of a mechanism where they also have visibility into what is happening in the IT. And you need to have a tight integration between all these teams, that is the dev team, the ops team, the business owners, and then the stakeholders. You need to have a mechanism to integrate all the tools and technologies. For example, sometimes you want to have a dashboard which business executive can also look at in real time and say that there are two builds that has gone to production today and it has gone successful, and that has increased my business transactions by 10%. So it is very easy to create a dashboard in an automated way and give it to the business executive. Nobody has to create an Excel sheet. Nobody has to create charts for them. It is an integration of multiple tools, and this enables the people to communicate better and collaborate better. Or sometimes the dashboard will be there for an application team itself or a development team itself. The dashboard will say that this metric, this new feature was deployed in so and so machines, and then that so and so machine is underperforming after the feature is deployed. So automatically a ticket can be raised and then it will be assigned to the developer. So the developer makes a call now. Instead of an ops team, the developer itself will make a call saying, yes, that feature is degrading the performance of the whole application. Let me roll back that feature. If you notice here, there is no ops team at all. It is everything is automated and the communication happens in an automated way. So you need to have a system which is going to improve the communication, improve the integration and collaboration of the teams. So when you have something like that, that is when you are going to say that you are going closer to DevOps or achieving DevOps. In other words, when you try to put all these things into place into your company or your team, what happens is the ops will start think like developers, and the developers will start thinking like operations. It is not that they will start going and coding. Develop ops guys are not going to start going to create user stories or front end screens or all those things. but they will be mindful of what developers do and what metrics developers need to improve the code. And developers will also know that what operations team needs so that they can provide the infrastructure which will meet the business demand. So it is a more of a give and take. Both of them will try to work towards a common goal. So, in other words, DevOps is a culture, in my opinion, or this concept or this philosophy is agreed by many people. DevOps is rather than seen as a tool or an automation or a build and release process. DevOps should be seen as a culture. It is a culture of lowering risk and the process of reducing the risk through tools. That is what you need to change, look at here. So it is not a culture means we are not talking about the civilization or culture of people or different races that are coming up. This is culture where everybody works towards a common goal, and that common goal is to release new features into production or new changes to production. And when you're releasing those new features, you need to reduce the risk of that feature impacting your existing services, and you need to use whatever tools are necessary to achieve that process. So that is what it is, a culture of lowering risk of change through tools. And when we talk about culture, there are different tools or different philosophies to it. These are all the most core concepts of the culture that tools has to bring in. When I say core philosophies, you need to have a respect. The developers will have to respect what the ops team does. There is each of the team members have to be respectful of what the other contribution, other players' contribution is. You cannot have teams with a different kind of priorities. Everybody has to work together here, and business operative executives or developers, everybody heads into the common platform and says that this feature is important and this feature has to be delivered with the support of everybody. So you cannot have impartial or imbalances within your culture. If that is the case, the operations team might not work conducively with your developer team, and that feature is not going to go to production very fast in a smoother way. Or if some issues are happening, the ops team is going to say that this is caused by devs. Let them go and fix it. Why should I go and tell them what is causing the issue? Let them investigate it. And if they ask me a ticket, I have an SLA. I'll work on that SLA instead of giving me an immediate response. I would rather wait for the 8-hour SLA or 10-hour SLA. So this is how you see respect comes very close, where people will have to work together, and trust also. You need to trust your operations team, saying that if there is some things are going wrong or some systems are not underperforming or not performing well, you need to trust your operations team to fix it up. And likewise, very importantly, ops guys should trust developers saying the new features have been tested and they will not degrade the performance or they will not crash the system. So trust also comes into a very, very important aspect of it, and there should be a healthy attitude for failure. When I say that, there is always a new feature is going to be there. You need to decide what happens when some things go wrong. That is when the true character of the teams comes into picture. Are you going to start blaming each other, or are you going to collaboratively go ahead and fix it? So combined to all these things, this culture has to be built from your team. And only when this culture is there, your DevOps is going to be successful. Otherwise, whatever tool you are going to deploy, it is going to be bound by that SLAs or OLAs or whatever contracts that you have between different teams, and they're going to find ways to break your DevOps workflow, and you're not going to achieve the productivity gains of a DevOps workflow. Just by deploying tools to move your code from developer to production, you are not going to achieve any business benefits without some of these underlying cultural changes within the teams. So we saw each one of those, and and this is sometimes this is a very interesting slide. I spoke about this. DevOps is incomplete or interpreted wrong, and it is too isolated. This is a regular expression. It means that everything has to be before ops. There is a business ops, there is an application ops, there is an infrastructure ops, there is a security ops. You have to see all of them together. It is not a DevOps alone. You have to have all the departments, and all the departments have to work with ops, and that is when you have your true DevOps, and that is when the productivity gains of your DevOps will be achieved. And these are some of the codes that I have here, which says about DevOps. This, as you can see here, this is not written by me. This is an ex-CTO of CA Technologies, one of the pioneers of DevOps. what he says is DevOps is not something you can buy. It is something you have to do, and you have to do it yourself. In other words, if it is a tool, you can go to a market and say that you buy the tool and then try to deploy it in your team and then try to make it work. For DevOps, it is not going to work in that way, because it's more to do with the culture and the philosophy of how the teams are working together and how the teams are built, rather than just deploying a tool itself. And having said that, tools are not completely irrelevant in a DevOps world. Tools are also relevant. In some cases, the tools helps you to solve some of the problems. For example, collaboration. You have a lot of tools like Slack, which is getting very popular in the enterprise world, and the notifications or collaboration. For collaboration, you have tools like a Jira or project management. You can have any kind of a project management tool for that. It's a project workflow. You talk to your client and then write the user stories. You give them an access to write those user stories. From those user stories, you will reduce them to functionalities, and those functionalities will be written as product features. And finally, those product features will be developed in Git, some language, and stored in Git. So you see, for collaboration, we are using one tool, and for communication, we are using one tool. For integration, you will use a tool like Jenkins. So there are multiple tools which gets used in the DevOps world. So tool also plays a part, but you need to remember that tool is not everything. Tool is just one piece of the bigger puzzle in DevOps world. So here you can see here, Git is the most common or most popular version control system that gets used, that you will see how to use it later today. And for the infrastructure provisioning, there are multiple tools are available: Jenkins, Elastic Container Service, Dockers, Ansibles, not Ansibles, Ansible. Ansible is getting popular, and it is backed by Red Hat. Sometimes there are situations that Ansible is very easy to configure rather than using your own CloudFormation script. So it is a trade-off when you want to do a VM-based deployment, that is virtual machine-based deployment. Things like Ansible will be working very good. But if you're doing a container-based deployment where all of your application is created in a microservices architecture, where every single piece of service is running as a container, then you don't need a tool like Ansible at all. So depending upon your DevOps deployment or your application architecture, you will choose the appropriate deployment strategy, whether it is going to be Ansible or it is going to be Kubernetes or ECS. In other words, in some container management system. Ansible is a version VM management system, whereas ECS and Kubernetes are container management system plus other things also. So when we come talk about collaboration, I hinted about these things. I would just put in the icon as a simple notification service and a simple email service. You also have the Slack integration also is possible, where tickets are automatically generated and thrown in the Slack channel for application team or DevOps team. And you can have other kind of notifications saying successful build happened, successful test happened, successful deploy happened. So any kind of notification. So your boss can also be part of the channel, or if you are conventional way, you can send him an email saying last night's build was successful. So those kind of collaboration tools are possible, and this is very use case specific. Each company has their own preference, and they try to choose the appropriate collaboration tool. Sometimes people use a very conventional way of doing just emailing for everything, or sometimes people use integration like Slack. Finally, in shared metrics, this is also a very opinionated DevOps implementation in terms of metrics. Some people use Grafana. Some people use Grafana as a visualization tool, which takes the data from CloudWatch in AWS. CloudWatch does a fantastic job of collecting a lot of metrics, but sometimes the CloudWatch charts are not so eye candy, I would say, whereas Grafana or Prometheus does a lot of better job of showing the metrics in a very nice dashboard. And of course, you can have some other algorithms also on top of it to create your own charts or create an alerting mechanism. For example, using the chart, let us say you find that the threshold is going above 80%, then you can take a notification from that, feed it into your cluster management system like Kubernetes or ECS, and ask them to do an auto scaling or a rebalancing or load balancing or fix the fault. So all those things are possible by using your shared metrics. And why it says shared metrics is an interesting question. Instead of just saying metrics, I would have just put it there as metrics. But when I say shared metrics, what it means is everybody in the organization will have a view of the metrics. It is not like the metrics as being only visible to operations team. It is not that metrics are visible only to your dev team. Metrics are visible throughout the organization. If you remember, I spoke about that in the early beginning. The line of business executive will also have a dashboard so that he can see what is the bills that has gone in and which team is working on which features and when he can expect which features can be deployed. So he can see all these kind of pipelines. He can create his own dashboard. Of course, somebody will create it for him, but he will have access to some of these real-time dashboards. And remember, most of these dashboards are real-time or near real-time. It is not a static of yesterday's data or last week's data. So you commit something to GitHub or you do something in the production, automatically the notification will get triggered, and then it will start reflecting in your dashboard as soon as they refresh it. So this is one very important thing that I want to highlight it before we move on to the next stage. This is not an easy thing when a customer comes to you and says that I am doing a waterfall method of deployment all these years and I want to do DevOps. Then the first thing you need to tell them that DevOps is a cultural change rather than a tooling change. It is not just deploying the tool, and you also have to tell them that it is not a straightforward journey. It is going to be a sequential, multi-stage process, and then only your team can achieve the productivity. In other words, this is not going to be an easy journey, but the other option is you can carry on shouting at all the other teams and not have the productivity gains. So the bottom you have a mathematical equation. If you can understand it, is awesome. It's like if you want innovation. Innovation is a product of your organization and architectural change multiplied by the mechanism and culture that you have in your teams. So if you want a higher rate of innovation, then change your organization and the architecture for the application and change the mechanism how people are working and the cultural within the organization. So that is what summarizes DevOps in one simple line, I would say. Tools helps, but tool alone is not the only thing. And finally, one of the pioneers of DevOps is Amazon, and this is the statement from them. If you are going to build it as an application team, don't throw it to somebody. You need to run it as an application owner or a feature owner. You are going to run it. So that is how the DevOps world is going to see it. So that is So DevOps continuous integration, what it means, that is the first thing that we need to understand. What is a CA? What do I mean by that? It is a practice again. It is a development practice where everybody integrates their work more frequently, and that leads to multiple integrations per day. That is the definition. What it means is like there are developers in US, developers in UK, developers in India, in an outsourced world. Some developers might be in different places, co-located, physically separated. So all of them developing the same piece of website. What they do is that the DevOps mandates that all of their core work is integrated frequently, or all of the work is integrated every day, so that there is multiple integrations per day. So remember the long pipeline, long integration problem that we spoke about earlier. To avoid that, what you need to do is you have to make it as a practice. Remember the culture we spoke about. We have to have a culture of integrating your work as frequently as possible. That will lead to multiple integrations. That means that there will be an automated integration. It will take the code that was developed by developer in California. It will take the code developed by a person in India. It will try to merge all that code. So when they come back tomorrow, the baseline code for both of them is the merged code. So they are going to develop on this merged code, and the possibility of having a defect is going to come down. If the merge is having any issues, both of them will have a notification by next day morning when they come back to work, saying that the work that you created yesterday is not working or compatible with the work that another collaborator done in some other part of the world. Go back and rework on this. This is the issue that was done. So this is what one of the benefits of integrating multiple times. So how do I do that? Now we saw what exactly CA is, continuous integration. So how do I go about and do that? What you do is each integration is automatically builded, or builded is not exactly the right term. Whenever you write a code, you need to package it in a way that it can be integrated into the whole code. That is, you are creating some functionality. It might be Python, it might be Java. So when you want to integrate it, you create a build package, and when that build package will include a lot of testing, whether that, for example, a simple login page example, will take it most easiest and most very easy to understand. In a login page, typically you will either have a username, have a password, and there might be some multi-factor authentication like a OTP code or some hash or some image or something that you will choose, so that it's the two-factor authentication. So these are the basic parameters, and you need to have a submit button. So this has to be tested, saying that the username has to be like uppercase, lowercase, cannot have special characters. Some kind of testing has to happen, and that username cannot be empty, password cannot be empty, or password has to meet some complications or coding standards or password standards. So all these test cases has to be tested against this login page code. So whenever I'm saying integration, it combines the build activity as well as the test activity. So each integration is verified by an automated build, which also includes testing, and detect that any integration errors are or popped up or identified as soon as possible. So this is how you are going to do continuous integration. Or when I say continuous integration, this is what going to happen in the underlying system. Whenever you commit a code, an automated build will happen, an automated testing cycle will happen. Once the testing cycle is completed, any errors are there, it will be sent back to the developer saying the code that you committed has these errors. It did not pass these many test cases. We ran 5 test cases, 4 of them are successful, one has failed. So you go back and fix the one test case, not the test case itself. You need to fix the defect, and then you come back and say that yes, this code is working. So this is how CI. This is how CI is implemented in production. There are tools to do that. We will see how the tooling will do this. Let us understand the concepts of it. So why do I need to do a purpose of CA? The long integration is one of the options. The other logical business way of looking at it is it improves your code quality. Whenever you improve your code quality, you automatically decrease the frustration of your team, or you decrease the frustration of your business owner, saying that any new feature is not going to degrade it, and you can be guaranteed that your business is going to be successful. And it is not just that, it reduces the communication gap with early feedback. When I say early feedback, remember the error that it pops up whenever there is an integration failure, and the error is automatically sent back to the developer. So there is a continuous communication between the different working teams, and it is also helps the testing team also to know that the number of test cases they are going to run is not always staggering. If you remember the previous slides, whenever the complexity of the system increases, the number of test cases increases. The more test cases, more bugs, and more bugs, not everybody is going to be happy. So if you have a constant feedback mechanism between the developers, testers, and different developers, this is going to create a community where everybody is going to try to reduce their or improve the productivity and reduce the defect and improve the customer satisfaction. So that is what it means. So if I can refer back to the long integration cycle, this is what in a typical CI works. You have different branches, and all of those branches are integrated, and it is never allowed to go too big. And whenever there is a different integration, there will longer integration, there will be more scrutiny or more test cases that will be run, and there will be release phases also planned along with it. We never allow a typical branch to go separately, and then it diverges so much that integration becomes a problem. So frequently you integrate all this code. So that is the whole idea. And the additional benefit is you are reducing the risk of uncertainty. You know that definitely your code is going to work because you tested it so much times, you integrated so many times. So you have a certain amount of comfortness when you go to production deployments. And CA is once again is a practice. It is not a tool. That is what you need to remember, and it requires a lot of discipline from the development team. Because if one developer forgets to commit his or her code, and the rest of the team has done that, and the work has progressed so far, and the last developer is committing at the last moment, and if it is not integrating very well, then we brought all the problems of continuous development, I mean the waterfall development, into the DevOps pipeline also. So it requires discipline also from development team. There is no way that you can enforce the behavior of commits from developers unless there is a business reason not to do that. They should be encouraged to integrate their work as soon as possible and as often as possible. You cannot have a tool to enforce that kind of a behavior. It is a cultural change. It comes back to culture and it comes back to discipline of the team here. So we saw the purpose of CI. Let us look at what is the process of CI. A CI usually has a development server. That is what a development activity happens in a desktop, laptop, anything. And what happens is a developer creates a code and commits it into a source control. And once the source control has the latest code, what it does is it initiates the CI process. That is, the integration process begins automatically. That is, the build activity will be triggered. If it is a Java file, a build means it will be created into a jar package. All the Java binaries, libraries, dependencies, everything will be packaged into a jar file, and then that jar file will be tested. Now remember the login page use case I gave you. You will be testing it for number of characters in the password, complexity of the password, whether the password is field is empty or it is easily guessable, all those kind of test cases. And once the test cases are passed completely, a report will be sent to a developer. It can be a successful report or it can be a bug defect also. So it can be any kind of a report. So how do I do that? What are the components in terms of servers and technology space? That is what we are going to see now. So at the bottom, you have three different developers all trying to write code, and you have a code repository here. Think of it, a GitHub, GitLab, Tortoise, or so any of the repositories. So, and then you have a CI server also. Typically, in conventional, most common is Jenkins server we are talking about here. But as a generic term, let us use CI server. And you also have a build server which will also do the testing functionality also. Sometimes test servers are different. You might spin up different containers. For easier understanding, let us say build server also does the testing. So you will have a monitoring system, or you have some kind of a triggers, so that the CI server will constantly monitor the repository so that it gets notified whenever there is a change or whenever there is a new code that is happened. So now you have all these components installed and configured, and you have set up the monitoring also. Now let us say my developer in the middle guy is committing some code to the repository. So what it happens is the new commit will be automatically detected by CI server. So it detects the CI server that there is a new code and initially needs to do a development. Once the development activity happens and completed, what happens is a build output will be created saying that there will be a jar file, var file, or whatever configuration file, and all the build outputs will be created. So the build outputs will be tested, and then the report will be sent by the CI server to the developers. It might be a rework, it might be good to go, or it might be saying that we are ready for production. And as you can notice here, the report is not sent only to the developer who committed the code. The report is sent to other developers also. It is very important because other developers should also know that there is a new version of a particular code has been is ready, so they can integrate it or they can build on top of it if they are working on something in something which is dependent on that developer's code. So a report is sent to all the stakeholders who are necessary or a part of that code. So these are the typical components of a CI, and this is what a typical industry also uses. So there is not much changes. You might see different tools being used for that. For example, if I can take an example here, in repository phase, you might have Git server, GitLab, anything, and CI server can be Jenkins, Travis CI, or Atlassian product or anything. And for build, people might use an EC2 server or for Java packages, or if it is a Python, they might just zip it. And remember the build artifacts I showed you in the previous screen. For that, they might be using Artifactory or some kind of a tool to store it. And the very simplest of configurations uses just an S3 bucket. They will just use an S3 bucket for binary files. They will use an S3 bucket for image files. There is another S3 bucket for configuration files, or in the same bucket they might have different directories also. It is how you want to implement these components, that is what it matters. What tool you choose depending upon what is your customer's willingness and comfortness and knowledge level of the teams. So if I can decompose it in words, it is a connection to a repository. You have a build script, you have a feedback mechanism such as email, and you also have the process of monitoring your source code whenever there is a modification to the source code itself. That is, you integrate your source code with your CI server. It can be either for test, it can be for inspection or deployment or feedback. So you constantly integrate your CI server with your source code repository. And once again, remember that whenever somebody says in DevOps, I am doing build is not just one activity. Build is a series of steps or series of processes. Remember, I spoke about testing also. Remember, I spoke about packaging also. Remember, I spoke about storing it in a different bucket or a version control mechanism. So build not just talks about just packaging that file. It has a lot of other processes, testing and putting it in the appropriate destination, sending a trigger notification for reporting and all those things. So build in CI means a series of process, not just one activity. Yep, that is what we spoke about rather than the so-called compilation that is executed. Build is a series of process. So what tool you can use? Jenkins is the most common cross-platform application that monitors the execution of repeated jobs. This is the most famous product that you can see in the market. Most of the team use Jenkins. There are other products available, but this guy has the cake as of now. On this slide just shows different tools that are being used by different companies in their products, but we don't have to focus on it. Just for awareness sake, it has been added here. So that's it for the CI process. CD, continuous integration to continuous delivery. That is what we are going to see now. We so far saw how to do continuous integration, why it is required, the purpose for continuous integration, and then the process of it, the components of it. That is all we saw. Now we have integrated, our code is ready, it is built and it has been notified to everybody, and now the next step is to deliver it. We need to deliver it into a production environment. So that is what continuous delivery means. So let us see what is that and how to do that. This is a typical slide which shows the continuous delivery cycle in an AWS world. If you are completely an AWS friendly person, you will use all the AWS technologies and tools that are shown here. For example, for code, if you want to store it in AWS itself, there is a product called Code Commit, and for build and test, there is a product called Code Pipeline, and deploy, you see there's a code deploy. I mean, this is, as I said, when if you are going to want to do everything on the cloud itself, you don't want to do in other words, SaaS model, service software as a service model. This is how you will do it. But if you want to have some more control over what happens on the background, if you want to have fine-grained granularity of what is happening, you don't want to have the features that is given by code commit, you want to have the control of the source code itself instead of giving it to Amazon, then you need to install your own tools and configure it. So let us see how CD helps us to do some of those things. When we are talking about CD, we are not talking about having a giant package of 5 terabytes or 6 terabytes of software code or a binary, and we are going to deploy it into production once in a year or once in 2 months or once in 3 years. Idea is to have small changes, very, very small changes or meaningful changes, and have frequent changes and integrate them continuously into production. Don't deploy a big chunk. And if I can quote my business manager, he would quite often say, I don't want a big bang transformation or a big bang deployment. I want it to be smooth, and I want it to be transitioned from one version to another version in the most smoothest way with the least amount of downtime. So in other words, we are talking about small frequent changes into production, and they integrate nicely into your existing code so that you don't have any surprises when you do a big bang migration. Because when you do, the disadvantage of doing a big bang migration is, let us say your deployment package is going to release 10 new features, and you find that 9 features are working fine and only one feature is not working fine. But isolating this one feature might not be easy on the day of deployment. You might end up with backing out all the 10 features, and then after troubleshooting, looking over the logs, talking to a lot of people, you find that 9 of them were working fine, only one of it was not working fine. Then you create another migration plan or a deployment package. and then you deploy everything together. If you're deploying one by one sequentially, and 9 of your changes would have been successful and only one of them would have caused some failure or some end of a degradation in performance. So smaller changes always has more confidence and more success, and facing your customers is going to be very, very easy when you're doing smaller changes and more successful changes. So here is what a Jenkins pipeline comes in for doing continuous delivery. So we were talking about the continuous delivery cycle, and a continuous delivery cycle. This pictorial representation gives you the current industry averages, I can say. Whenever we are talking about a waterfall model, that is a conventional method of development. If you have a big bang transformation or a product development with multiple features, sometimes it takes months, sometimes it even goes up to years also. Recently, we took over a project from one client where an outsourced vendor was not able to deliver the promised features after 1.5 years of development, and we had to take over that project, and we are working on that. We have already got our first release with the minimum features already, and customer is okay with that. I wouldn't say it is a flying success just because we have taken it over, but we changed the approach. The customer did not want a big bang waterfall model. They wanted an iterative development that you see in the next circle, and that is what we have been done. We did a 6 weeks of proof of technology, and we showed them what exactly can be delivered, and they were happy with that. So the next iterative development is going to start after this first review is completed. So there is a Kanban, or it's a Japanese word. It's from a manufacturing industry, or a pull method. So whenever a feature is required, that is when you start the development. You don't work in the left to right. You work it from the right hand side to left hand side. So whenever it is a just in time feature, whenever something is required, only you start going and developing it. It's nowadays you get these kind of concepts getting applied to development of world also. Kanban development is getting popular nowadays. Just that the user stories and then what features has to be there. So you work in the reverse direction, and then you try to work in the functionality and then start building it. Finally, once you have built it, are going to have continuous delivery. So in a way, it is agile in an accelerated way. So if you remember the smooth collaboration slide that I spoke about yesterday or in the previous video, if I can quickly jump to it. This is a visual text that I was referring to. This talks about agile development in a DevOps world. So you will have continuous multiple sprints happening for multiple, and there will be bigger releases happening, and there will be separate teams working on that, individual teams, where the addition is your ops also is working with the dev continuously, and there is a feedback loop from the ops team to dev team. So in an agile world, at least I have not come across where that ops team works with the dev team. It is only the sprints where agile team only work on. Now we are talking about integration of the ops also, and you are talking about packages, build packages which are small and easy to release, which can individually run on its own, and it can integrate very well with the existing code. So it is a next phase of agile development. Agile is a core part of DevOps. It is not something sits outside it, but DevOps imbibes all the good qualities of agile and takes it to the next level by having feedback from ops teams and having modularity, replaceability, testability, and all those native architectural concepts into the DevOps world. So we saw what is continuous delivery and what is the different iterative cycles that usually takes to deploy code, waterfall method, in iterative development, Kanban. Now let us see why we have to do that and what is the benefits that you have to do. What happens is when you are developing the code in an accelerated way, it makes more sense to release it into the production. You might do what amount of testing you want in your simulated environment, but releasing your product to your end customers and getting some real feedback from your end customers is when testament for your product survivability. Because if your product is delayed, or if there's a competitor's product which is going to have the same feature or better features, people are going to have a choice, and whenever there is a choice, the amount of traction for your app or a website is going to come down. So you need to release it more often, and for releasing it into production, continuous delivery is the sound choice and works very well with your DevOps philosophies. So it is always important to have a continuous delivery also built into your DevOps pipeline. And when I say DevOps pipeline, it talks about CI and CD also. And when I say CD, we are talking about continuous delivery only. There's another concept called continuous deployment. We will see that next. So there are delivery principles. This is all more on a management side. When you're setting up the team, remember the culture and philosophy I spoke about. There are certain principles that you need to follow. There is a quality of the code has to be given utmost priority, and the safety. When I say safety, we are not talking about a physical safety. It is the safety of the product itself. The product has to be risk-free, or in other words, you should have more confidence in releasing the product into the production, and it should increase the effectiveness for everybody involved here. You cannot have the old process brought into continuous delivery and then try to call it as continuous delivery. You need to have an automated mechanism, and then you need to have an automated rollback mechanism also if something goes wrong. So these are some of the core principles. When you are evolving your continuous delivery pipeline, you need to have it in mind. These are the common practices. I'm not going to spend much time here. This is a pretty much a software development lifecycle practices that gets used everywhere. This is a pictorial representation of a continuous delivery. At the top layer, you have your version control system, and then once your version control system, you are committing to stage, and then there is a build package that will be created, and it will be stored in your S3 bucket or some kind of an artifact repository. And once the artifact repository gets updated, the build commit stage will send a notification to your acceptance stage. Think of it as another environment that is there, and this environment will again do some more processing, and then it will have your performance tested, and then it will be done with the UAT testing, and then everything is successful, then the code will be sent to your production. So that is why it has connectivity to all of that, and your configuration management tools will also have notification triggered from the acceptance tools, because a new package might need more CPU, more memory. So your configuration management tool will be notified, and the new VM or a new Docker container or a other container with more memory and more resources will be started. So when you're architecting for continuous delivery, if you are going to work as a DevOps architect, you need to understand, have you automated all of your deployment tasks, or is it some task that needs to be manual? Then you're not going to have continuous delivery in that case. So this is the most important question that you need to ask when you're doing continuous delivery. All the tasks, irrespective of what it is, has to be automated, and it has to be done in a script or tool-based deployments. You cannot have manual intervention. You don't want people to log in and then you do that. And then, can you transform a brand new development environment of running your architecture without manual work? This is the question. In other words, you are trying to ask, can you do it without manual work? Or is there any amount of work that is still being done manual? Then you need to try to automate that piece of work also when you are trying to do continuous delivery. Finally, there is another question that you need to ask is, can you vary your configuration across environments without rebuilding your code? Have you made it modular in other ways? You should not be trying to, just for one comma or a one parameter change, you should not be rebuilding your code. That should be, the parameter alone should be able to be changed in all your environments without much effort. These are another architectural practice that you need to ask yourself. And finally, there's one more question that you need to ask is, architecting for continuous delivery. Can you do it without your users noticing? Remember the Netflix example I spoke about for Chaos Monkey. The idea of having a Chaos Monkey is, whether you're deploying a new change or maintaining your website at the same level, your users should not have any impact at all. Whether the code is running in version 1, code is running in version 2, 10, whatever it is, you need to have systems which are always up and running. So this is another thing that is, if you're, as I said, I gave you a real life example where a single line of code was charged a huge amount of dollars for the customer. So make a delivery in such a way that you don't have to change everything for doing a single line deployments. In other words, that is what continuous delivery is all about. Small, frequent changes which can be integrated to production. So the what part of CI is every change can be integrated, or the first line that you can see here, every change to the system can be released for production. That is, it might be the smallest change, it might be the biggest change, it can be deployed to production, and delivery can be done anytime on any environment. That is how your change has to be packaged. So you cannot say that I will release it only in pre-prod today, it is not production ready. If there is a change which has been committed and passed with all the checks, it should be ready for deployment in any environment, and it need not necessarily has to be happen at a midnight delivery. Most of the big bang transformations happen at midnight or peak off peak transactions. So you have to prioritize your deployments of software, and rather than working on new features. So your team gets this choice. Your development teams has to have the discipline and have to see whether my software is deployable, or I'm going to work on only new features which might not be deployable easily. So this is a discipline or a culture change your development teams has to imbibe when they're trying to adopt DevOps practices. How do I do CD? One of the best and easiest use cases is you can have a Jenkins pipeline configured it, and then once the build is successful, the Jenkins pipeline will trigger a deployment into your ECS or EC2 or Kubernetes clusters. So that is one of the easiest way people deploy it. And in other words, the thing that you need to remember here is configure it as a deployment pipeline in your CI tool. That is the most easiest way you can do it. So CD is not continuous deployment, because you can see here there is a two different checkboxes that you have, or markers that you have. If after acceptance test, if you're going to somebody's manually is going to approve it and then going to deploy to production, then it is going to be called as continuous delivery. But if you are going to be completely automated, then we are going to call it as continuous deployment. The reason is sometimes people still like to have manual control over the last mile deployment. People who want to decide where they want to release it. For example, a new feature might be tested and they don't want to release a new feature to all over the world, because say a simple example is China has some restrictions over encryption, and if your product is going to add encryption to your communications, China is not going to allow your product to work at all. So you need to comply with the Chinese government policies to run your app in the Chinese mainland. So there is a possibility that you can have a manual deployment where manually you will deploy it only to certain environments only, and then not to deploy to certain environments. It's just an example. You can have any kind of examples or scenarios. I just thought of this simple example where a manual intervention is required before you go to continuous delivery. And when you can fully automate it, if it is a new feature saying that you added some smileys to your chat, then go ahead and deploy it using automated deployments, and you'll end up with having a continuous deployment pipeline.